Next thing up here is structural formulas. So we've looked at empirical formulas, looked at molecular formulas, now we have structural formulas, how they're arranged. Don't worry so much on this, as we'll look at it in more detail when we're getting into organic chemistry. So don't worry, it doesn't make much sense. We'll tip away through it. So the structural formula, your definition, it indicates the arrangement of the atoms within a molecular compound. If you know that at this stage, we're laughing. So that means like ethane, the structural formula of ethane is as follows. And I say, once we get into organic chemistry, hopefully when we return to school before the end of term, you'll have no bother drawing that. The molecular formula of that indicates how many of each element is present. So we've got C2H6. And then your empirical formula, the simplest whole number ratio, dividing it by 2, we get CH3. Say do the revision questions, page 184 of your textbook, you'll be flying. Now look at balancing equations, and we're nearly there then. So balance equation is something we've seen before, trying to get the same number of carbons and oxygens on either side of the equation, and taking care not to change the molecular formula. We can only change a big number in front. So if I look at this, I have 1 carbon on the left, I've got 1 carbon on the right. I've got 2 oxygens on the left, I've got 1 on the right, so we must balance that up. So I must stick a big 2 here. Can't put a 2 here because you've changed carbon monoxide into carbon dioxide. And by sticking that big 2 there, I have 2 carbons here, I must have 2 there, and we balance it up. This next one, looking at the combustion of methane, I have 1 carbon on the left, 1 on the right, 4 hydrogens on the left, I have 2 on the right. So how am I going to get like that 4? Put a big 2 there. I have 2 oxygens on the left, here I have 2 and 2, I have 4 on the right, so I must fire on a big 2. So don't be scared to pause this video, try them yourselves, then have a look at the answers. And say sometimes you might have to go back and change it again. But you fitter about and you will get it. This last one here, on this page, so 2 nitrogens on the left, I have 1 nitrogen here on the right, so throw on a big 2. When I throw a big 2 there, I've now made 6 hydrogens. 2 of these pyramidal shapes resulted in 6 hydrogens, and put a 3 there. 3 and 2 is 6. I'll do a few more of those, because this links into the last bit of these stoichiometry questions on balanced equations. That's where it gets nice and tasty. Over here, 1 magnesium, 1 magnesium. 2 oxygens, 1 oxygen, so throw a big 2 there. And by throwing a big 2 there, I now have 2 magnesiums on the right, I need 2 on the left. And below that, 2 hydrogens, that's good. 2 oxygens, 1 oxygen, throw a 2 there. I've got 2 oxygens, 4 hydrogens, I need to throw a big 2 there as well. This one, 1 sodium, 2 chlorines, 1 chlorine, throw a big 2. So keep pausing it, try them yourselves. 2 chlorines, I've changed the number of sodiums, throw a big 2 there as well. And it all balances up, same number either side. 1 potassium, I can see there's 2 potassiums on the right hand side, so stick a 2 in front of that. No, can't do that yet, rushed. 1 potassium, 2 oxygens, and 1 oxygen here, so stick a 2 in front of this. So I've got 2 oxygens and 2 oxygens, and now you can see there I've got 4 potassiums, so I have to go double change that, so go back and change it again. So 4 potassiums over there. Over on this side here, Zn, I have 1 chlorine on the left hand side, I have 2 over here, so stick a 2 in front of this. Now I've got 1 Zn, 2 hydrogens, 2 hydrogens, that's okay as well. And below this, H2SO4, that actually looks okay. So I've got 2 hydrogens, 1 sulfur, 4 oxygens, 1 Zn, that actually is balanced. One below that, 2 hydrogens on the left, 1 on the right, stick a 2 in front of this. 2 chlorines on the left, 2 on the right now of that 2. And the last two here, iron. So one iron, one hydrogen, two hydrogens. So we'll try to stick a 2 in front of this. Now you've got 2 chlorines and 2 chlorines, so we're good. The last one here, aluminium, 1 Al, 2 Al. So maybe try to throw a 2 in front of. If we put a 2 in front of this, we might have to go back and change it. And then we have 3 oxygens here and 2 here. So, well, I would probably just say there, it's 3 over 2, or 1.5. 1.5 times 2 is me 3. Someone else might have wrote that as 4Al plus 3O2 gives me 2Al2O3. Doubling everything, bringing across the 2. It's the exact same. 4, 4, 6, 6. Right, try those again and work through them yourselves.